So thanks, Jen, for the great introduction. As Jen mentioned, my name's Lon. I work at RetailMeNot. And what I do there is I focus on frameworks and tooling and also on performance. And that's that last piece that I want to talk to you all about today. Specifically, we're going to talk for a little bit about how to do performance experimentation and how to do it in a way that's rigorous, meaning you have like a clear and formal process about how you go about it. That it's reproducible so that other folks can reproduce your results and basically do the same experiment, get something like the same result. And rapid, this is the tricky part, so it doesn't take forever. So before we do that, I want to just motivate the talk a little bit by clicking to the next slide. This is all going very well. Okay, so why do we care about performance? I think a lot of us probably feel performance is important, but we really want to ground that into actual like user motivations and business reasons. And so today we're specifically going to be talking about page load performance. And so the first reason I want to we care about performance is because our users care. So there are like tons and tons of studies out there that show that when users interact with faster websites, they do more of the things that we're hoping that they'll do. They buy more stuff, they click on more links, they read more content. Recently, there's a super awesome study done by Sawasta, who is now owned by Akamai, and they aggregated page load performance results across like thousands and thousands of sites and millions of page loads. And they analyzed what the user results of those were. And so the first thing that they found is that users buy more stuff if your site is faster. So specifically what they found is that conversion rate, basically meaning like if you're selling something that the user actually buys something, if you're trying to get someone to download something that they actually download it, that there's a clear drop-off as your site gets slower and slower. The next thing they found is that users don't wait around for slow sites. They bounce, they take off, and they found a clear relationship between as a site got slower and slower, users were more and more likely to give up and leave. And this makes a lot of intuitive sense. And the other one, and this one actually surprised me until I kind of thought about it, which is that users interact more with faster sites. Basically, their session length is longer. They click on more pages. So what does that mean to the business? That means you have more opportunities to sell something. You can show the user more ads, and the user uses your site more and is more likely to become a loyal user of your whatever it is that you're building. So the other reason is that Google cares. Some of y'all may be aware that Google recently pivoted their entire developer relations team to shaming developers of slow websites on Twitter. But this is actually something they cared about for a long time. Site speed was actually first publicly announced as a legit ranking signal 7 years ago in 2010. And something that they announced recently, people kind of knew this, but they actually made it clear and said it out loud, which they don't do very often, is that the Googlebot will actually crawl your site more often if your site is faster. Why does this matter? Because if you're updating your site, the Googlebot likes fresh content. And basically, your content from the Google's perspective can only be as fresh as the last crawl. So the more times they crawl your site, the more likely they pick up the new cool content that you just uploaded. All right, so before we move on, I want to just set out some key terms and concepts so we're all on the same page. This shouldn't take too long. A lot of times when we talk about performance, you immediately go to like thinking about speed. But really, like there's lots of different kinds of performance. There's performance in terms of speed. There's performance in terms of like size, battery life. And really what performance is about managing resources. You are trying to produce a result, you're trying to do something, do some work, and you have to consume resources to do that. And so performance is the sort of discipline of figuring out which resources you're going to use and in what amount in order to produce that result. Hopefully try to use less, but it doesn't always work out that way. Sometimes you have to trade off one resource for another. The resources we're most often interested in computer programming and computer science in general are time and space. They're sort of the classic duo. But I did want to briefly say that there are others you should be thinking about, battery life being one. And there's a good example of this, which is like a feed, okay, like Twitter or Facebook, where you want to show fresh new content at the top of the feed as it comes in. But there's a trade-off between how often you can show new content and battery life on phones, because to get that content, you have to make a network request, which usually means waking up the radio. That costs battery life, so you have to balance those two constraints. The user wants fresh content, they don't want you to drain their battery. So what we're going to talk about today is speed, and so I want to talk about two important aspects of speed. The first is latency. Latency is basically how long it takes from start to finish to accomplish a task. And I want to contrast that with throughput, which is basically how much work can you do at the same time. It's still going to take the same amount of time for that work to go from the beginning to the end of your process. You can just do more of it at the same time. The analogy that I like to draw is when you're moving. So let's say you have a pickup truck, and you can't fit all your stuff in the pickup truck, but you're just moving across town, so it's fine. You're going to drive the pickup truck, unload it, come back, load it back up, drive over. Maybe it takes 2 or 3 trips, not a big deal. If you're moving from, say, Austin to Dallas, now it becomes a big deal. You're going to need a bigger truck, because every single one of those trips takes a lot longer. Today, we're mostly going to be interested in render latency. And the reason for that is because latency has become the dominant performance factor on the web, mostly because of mobile. Mobile connections tend to have pretty good bandwidth, but they're very latent, meaning it takes a long time to download the thing that you're getting. It takes a long time to communicate with the server. All right, so before we get to an actual experiment, let's cover the rigorous part of our discussion, which is how do we do an experiment? Y'all may remember this from high school or middle school. It's the scientific method, right? So you have a question. Does gravity affect things that weigh more, two objects that weigh different amounts? Does gravity affect them in differing amounts? So you form a hypothesis. Let's say your hypothesis is, no, it's exactly the same. So you find 2 balls, but one of them is denser than the other one, and so one of them weighs more, in other words. You take them up to the top of the Leaning Tower of Pisa, and you drop them. And you observe what happens. They fall at the same rate, they land at the same time. You do this a few times. Now you've gathered your data. And so this is the testing the hypothesis part. Now you've gathered your data, and you analyze it, and the conclusion that you draw is, yeah, gravity does not care about weight. Gravity affects all things at the same rate, no matter what their actual weight is. In performance experimentation, things look a little bit more like this. So the first thing you're going to do is you're going to identify the metrics that you're interested in. Then you're going to measure baselines. In other words, what is your current performance on these metrics right now? Then you're going to set a goal, because it's important to have some reason that you're doing things and not just sort of like make stuff faster for the heck of it. And then after that, you want to identify a potential optimization, you implement it, and then you measure the result. And then once you're done with that, you look at how far you've gotten versus your goal, and you either keep going or you're done. So for this, I've chosen a motivating example, so it'll be a little bit easier, and y'all can actually follow along if you like. It's the React's To-Do MVC app. I chose this because I want to make clear, this is not a critique of the performance of React. This To-Do MVC project, if you're not familiar with it, it basically is a project where they take a bunch of different frameworks and they implement the same to-do app in these frameworks. And it's so that someone who's wondering like, well, what is it like to do something in Ember versus Angular versus React, you can go and look at these things and get some sort of an idea. There are critiques about how good of an idea you get, but it's something. And I specifically chose this project because since it's intended for learning, it's not optimized, and so there's lots of easy performance wins. I did want to actually specifically apologize to Tom. I was going to use Ember, and I told you not to dress up for my talk, but unfortunately, the list of potential optimizations was like super short. So let's identify our metrics. The metrics we care about, we're trying to optimize page load. And the SOASTA results are actually tied to the load event in the browser. But we're going to do something a little bit better, is we're going to think about the user's experience of the page load. Because the user doesn't like get the load event, you know, nothing like pops up and says, it's loaded. The way the user knows that something is loaded is that everything that they can see is painted. And so we're going to specifically consider 2 metrics. First paint, which is how long it takes the browser to paint anything at all above the fold, where above the fold means what you can see in your window before you start scrolling. The other thing we're going to look at is visually complete, which basically means the browser is done rendering pixels, everything's done, we're finished. This gets a little tricky when there's like rotating carousels and things like that, but fortunately we don't have to worry about that. So, the next thing we're going to do is we're going to measure baselines. How do you do this? Well, I have a couple tools that you guys can take a look at. Y'all can take a look at, excuse me. The first of these is Chrome's DevTools. On the Network tab, you can actually click, there's a little camera icon, and if you click that camera icon and reload the page, Chrome will capture what they call a film strip. And what a film strip is that every single time a paint occurs, they take a screenshot, a small thumbnail screenshot. And so you can actually see, and they put the time next to it, so you can actually see like, when did different paint events happen? And you can see, if you look up this, well, the contrast isn't great, but basically you can see that there are 3 paint events. The first one doesn't really count. That's more of a like first load. And then the second one was, the first paint was at 2.95 seconds, and we were visually complete at 5.19 seconds. Another important thing is that you want to disable the cache. Generally, when you're doing performance optimization, you want to think in terms of either a cold cache, meaning the user doesn't have anything in their cache, or a warm cache, like a second page load. For many retail websites, the cold cache case, particularly on phones, is almost always going to be what you're dealing with, barring service workers and other such shenanigans. And then the last thing you want to do is you want to throttle your network, because your desktop likely has a super fast, very low latency connection to the internet. It's highly unlikely that most of your users are going to have that. They're going to have a mobile connection. And the DevTools has awesome abilities to pick pre-chosen profiles for like 3G versus 2G, and you can even set up a custom one. And so you basically can reload this page, get a result, write it down, reload it again, get another result, because another part of being rigorous is that you want to gather enough data. Whenever you see like a performance thing on the web and they like did it once and then they tell you that number, you can't really trust that number, because every time you make a request across the internet, your request is going to take a different path, your reply is going to take a different path, your browser might be doing something in the background, there's all this variance. And so what you have to do is you have to take a bunch of samples and then figure out like what is the picture that is painted. I usually do 5 to 10, but you can go more if you have really noisy data. It's a bummer to do this manually using the DevTools. Fortunately, there's another tool called Web Page Test. Web Page Test, besides being a little bit janky looking, is the tool for measuring performance, and it allows you to do all kinds of customization of the network. It's scriptable. Most importantly, you can tell it, I want to do this thing 5 times, or I want to do this thing 7 times. So we're going to be using that. And here's where you can set it up. You can configure a custom network profile. You can say how many times you want the test to run. First view only tells it to only use the cold cache case. And then finally, you want to be sure when you're doing these tests that you capture video, because otherwise you won't get any of the rendering metrics, or you'll get a lot fewer of the rendering metrics. So once you do that, you run Web Page Test, and you get some results. And for every single run, you can actually click in and see like what were the network requests that were made, and when did they come back, and all this stuff. I'm not going to talk about any of that right now. I've linked to some documentation on a lot of these pages for y'all to like dig in a little bit deeper on these tools. I just want to bring this teeny little link to y'all's attention, and it says plot full results. This is what we actually want when we're doing a performance experiment. It takes you to a page where it plots every single result from all the different runs, all 9 runs, and it allows you to look at some summary statistics, the mean, the median, and some other stuff, and actually get a good picture without having to do all the math yourself or fiddle around with Excel about the performance that you observed during this run. Okay, so now we have our next thing, which is we're going to set a goal. Our goal is going to be to improve the time it takes to finish rendering the web page without taking longer to start rendering the web page. Because both of these things are important. When your page is blank and you haven't drawn anything at all, as far as the user is concerned, it's not working, right? Like after a while, they can be like, well, all right. So it doesn't do any good if we make If we paint at like 4 seconds instead of 5 seconds, but we don't start painting anything until 4 seconds. So you really want to do both. And here's some numbers from the baselines. Next up, we're going to identify an optimization. This is like the real tricky bit, because like there's so many different things you can do to make websites faster. There's like a bazillion moving parts. Fortunately, there's some really good tools out there. Page Speed Insights is one. This will, it's a super simple website. You plug in the URL, you click the Analyze button. Google will request your website a couple times, run some heuristics on it, and tell you, hey, here's how you did. Here's some things you can improve, and here's how badly what you need to improve and why. As you can see in this screenshot, React, the to-do MVC doesn't do so hot, 60 out of 100. And this metric, the 60, is actually what, I believe, what Google uses as the signal into their rankings algorithm. So that's useful, but there's actually a really cool tool that has just recently come out called Lighthouse. And y'all may have heard of Lighthouse in the context of these progressive web app thingies. And it will help you with that, but it also has a super awesome performance audit feature. And what's great about Lighthouse is that it used to be a Chrome extension that you'd have to go like install, and who wants to do that? But now, as of Chrome 60 Canary, Lighthouse is actually going to be built into the audits tab of Chrome, which is super, super great. So both tools report a bunch of things that we could do, but they also both report this idea of removing or inlining render blocking CSS. And so I picked that as a good example to do a performance experiment on. So now we've identified what we're going to try and optimize. So what is render blocking CSS? The basic idea is this. The browser is reading your HTML file, and it encounters a link that references a style sheet. It has to stop because those styles are going to decide what the page looks like. So it can't like draw a bunch of stuff and then change all the colors and sizes after it gets the style sheet back. And so if it's a link tag, it actually has to make a network request, which can take a while. It's a little hard to see, but this is from the React to-do MVC, and it took almost a second to download a 1.8 kilobyte file. That's like dial-up in like 1992 speed, all right? Like, this is not good. So the inline CSS pattern goes like this. For users with a cold cache, the first time they come to your site, you don't put a link tag, you replace the link tag with a style tag that contains the contents of the file that the link tag references. In other words, it's inline right into your HTML payload. Now, this is going to make the HTML payload bigger, but because latency dominates and the browser now doesn't have to make an extra request, you're actually likely to render a lot faster. Now, if you're getting really fancy, there's a bummer here, right? Because that CSS may get reused on multiple pages, and now it's not in the browser's cache. So you can actually use JavaScript to asynchronously add the link tag after you've rendered. The browser will request it. It's all the same style, so no changes occur. Now it's in the cache, and then you set like a cookie or something so that your server knows, not to do that operation on the next request. So we're going to implement this. So that's the next step. This is where things get a little tricky. So it's pretty straightforward to do this in the React to-do MVC's code base. You just like find the CSS file and paste it in there and change some tags. But now at a minimum, you have to like host it somewhere because web page tests can't, there's no URL from your like laptop that web page tests can hit. Perhaps you use some sort of tunneling thing, but either way, like there's some work that needs to be done. More importantly, in like a production website, this could be like really complicated. You might have to get multiple teams involved. There's like a build system. You may not control some of the styles that are actually in the page. And so if you're trying to figure out in a short amount of time, is this thing going to be a win or not, you really want to do something a little bit simpler. And this is something that I struggled with a lot. And so I did what engineers often do, and I built a janky tool. The tool is called Ground Hard Day because you relive the same experience over and over again. The basic idea is this. There's a file format called an HTTP archive, and what it does is it captures all of the requests and responses during the course of a page load. And importantly, in Chrome, that it also includes, when you capture it from Chrome and from certain other tools, it actually includes the payloads, everything, even images. They're base64 encoded, so it's all in a big JSON file. So that's cool. You upload it into GroundHardDay, which is a VirtualBox Linux VM, and it basically does a bunch of virtual networking stuff and reads the HAR file and spins up servers, Node.js servers, and arranges all the networking inside the VM such that if you have a browser running in the VM that says, take me to todomvc.com, you don't go to the internet, you go to the simulation. And this means that you can do stuff like you can easily vary all the network requests and like you can condition networks and you can like take down a CDN and say like what happens if this one server is out. And that's cool. It's less cool than what I'm about to talk about, which is you can edit the HAR file, right? So now we take this HAR file and we actually do the replacement. We find the part of the payload that has the link tag, we find the styles, we just drop them in there, we upload it into the VM, and now we can, within a few minutes, be interacting with that modified website without having to deploy anywhere or commit any code or do a code review. So it really tightens the iteration cycle. And what you end up having is this sort of workflow where you capture a HAR, you edit it, you upload it, and then you measure it. So GroundHardDay ships with headless Chrome inside, so that makes it very straightforward to do your performance monitoring or measurement, with Chrome. It's also possible, I've done it once, to run web page tests in a VM locally. This is non-trivial, it's a lot of work, but eventually you can do it, and then you can have web page test talk to the VM, and when web page test in this other VM says, I want to go to todomvc.com, it instead hits the simulated website. So, we've got all this in place, let's measure some results. And what we actually found, what I found when I ran this at the hotel room before I headed down here, is that time to visually complete is in fact faster by 200 milliseconds. And this makes sense because 200 milliseconds is about how long it takes to do the round trip request for that file under the network conditions inside the VM. So that's awesome, great, we hit the first part, but the next part of what we wanted to do is we wanted to have time to first paint not be regressed, right? We wanted to not hurt that, and what is great news is we didn't hurt it, and in fact, we made it faster, also by 200 milliseconds. So all around a success, ship it. Which brings us to the last part, which is iteration. So we've made things 200 milliseconds faster. There's a ton of other stuff you could do to make this web page faster. I'm not going to go into it, but what's cool is that some of the things you can try out are actually really hard to do. For example, you could enable HTTP2 and see what the effect is of doing that. I don't know if y'all have ever tried to set up HTTP2 on like a real website. It takes forever. You have to get everybody involved. You have to like talk to your Akamai representative and like do configuring stuff, and like it's a nightmare. So the great news about this is that GroundHardDay supports H2 out of the box. So instead of doing all that, you open up the HAR file, you replace all the occurrences of HTTP 1.1 with HTTP 2, and then you load it up, and bam, you have actual hard numbers that you can take to your boss or whomever and say, here's how much faster we'll be if we implement H2. So hopefully I've made a case for doing sort of rigorous and reproducible experimentation and given you all an idea of what possibilities are out there for doing it a little bit more quickly. You can check out the GroundHardDay GitHub. It's linked from the slides. This is all, as I said, a very janky tool. It's very new. I'm hoping to have an opportunity to polish it over the next few months. And I would love any help that anybody was interested in doing. And with that, I'll say thanks. I'll just start working.
Hi.
Hi.
It's so interesting, but like not surprising how much everyone's talking about performance these days. It's like we just sort of ignored it for a while, because I guess like it used to be like, okay, my app is done or my site is done. Now like here's the hard part, open it in Internet Explorer. And, and now we're kind of like, oh, if that was only all we had to do now in order to actually like test things. What I'm seeing a lack of, though, like in this conference schedule, a lot of conferences and performance talks, is how I feel like sometimes performance butts heads with accessibility.
Yeah, absolutely.
Yeah, I'm wondering like how like you've encountered that and like how you've like gotten past that. 'Cause like I think of like a lot of people are like, oh, like CSS does this faster than like JavaScript does. Meanwhile, like JavaScript sort of like makes it more accessible. There's these trade-offs that we have to have. Like, how do you handle that?
So that's a great question. Accessibility is super important. I had the pleasure of working with Brian Sinclair at Bizarre Voice, where we took it very, very seriously, and I learned a ton about it. It doesn't have to be, so first I would say performance is something of an accessibility issue, because folks with lower-end devices shouldn't get a lower-end experience on the web just because you can't afford a super fast connection. And in fact, broad swaths of America, typically of lower income levels, get their internet over a phone. They don't have a laptop, they don't have broadband. And so I would argue that having good mobile performance, that's a form of accessibility. And the other thing I would say is that for many websites, that like runtime performance, like for a while everybody was all about like, oh, is Ember faster than React or blah, blah, blah. That's less important than the actual network performance in my experience. It can be an important component. You need to pay attention to it, but for most users who are on mobile phones, the network is going to dominate performance, and then you can deal with this other stuff later.
Cool. Yeah, I talk a lot with like content publishers, and you know, there's like the phrase like content is king, and then I had said to them like performance is king, and it became this debate, but it was like a non-issue because really like you need to have performance in order to show content.
Yeah.
And I think one thing that we're seeing is like as we're building web apps that are like more performant, we're seeing like news sites adding ads to, you know, their applications that then make it less performant. Like, I mean, who here has built an app and it was all perfect, and then like marketing was like, okay, now pop all these like third-party scripts into it, and you can't do anything about it. Like, is that something that you have to deal with, like, on your product?
Yes. Whenever someone wants to do a new third-party script, I get an email, and I have like a pre-canned response that goes along the lines of, no, okay, if we have to, it has to be fast, and you have to show it to us. And the reason that I'm able to do that is because Retail May Not has had a culture of performance going back years and years, predating my time there. And so multiple sort of generations of engineers there have shown with data that performance matters to our users and to the revenue bottom line of the business. And so when marketing says, you know, oh, these people pay us $50,000 if we take pictures of our users, we could say, well, yeah, but that thing makes our website slower and we lose $500,000. I want to be clear that all of that was purely hypothetical.
I always just love like being like, okay, this site's done. Okay, now put this like Facebook like button on it.
Yeah, no, it's so we have some pretty hardcore rules about how we load third-party scripts. It's always async. We don't allow, with the exception of Google Analytics, I think, we don't allow anything to actually be on the critical render path that is third-party.
Awesome. Thank you. Also, Italy's lawyers called, and they said, please do not throw weights off the Tower of Pisa. So besides that, thank you very much, Lon.
Thank you.